In this lesson, I will explain to you support vector machine, which is known by SVM in machine learning, and this is the important topic in machine learning as well. So first of all, I will explain to you a few things, then we will read this very slowly, then concept will be clear to you. So as you know that in machine learning, we have three kinds of learning: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we learn about regression and classification. So SVM deals with both regression and classification challenges, but mostly it supports classification. So simply you can say that SVM comes under the category of classification, which belongs to supervised learning. Right, and in supervised learning we have labeled data. Now same thing I have written here. SVM is a supervised machine learning algorithm which can be used for both classification and regression challenges. However, it is mostly used in classification problems. SVM is a linear model for classification and regression problems. Now see, the word is linear, and I will show you with the help of example what is the meaning of this. Linear model for classification. It can solve linear and non-linear problems and work well for many practical problems. And the most important thing in SVM that we have to find out the hyperplane. So what is the hyperplane? I will show you with the help of example what it does. Hyperplane which separates the data into classes. Right? Okay, so here I have set a very simple example for you. Suppose we have two different kind of cells. This is the benign cell and this is asterisk means the malignant cell. So first of all, what we do in machine learning, we create a model. Right, these are our two different cells, benign and malignant. We make, or simply you can say, we train the data, we make the model. This is the training phase, or we make the model in the training phase, and then we test the data right here by using the dot predict function in Python, which I will show you. So this one, and then is the prediction. After prediction is the output. Right, if our model is very nice or accurate, so it will give us a right output. When we will test some data, suppose if I will give this circle benign cell here, the output, the model will give us that this is the benign cell if our model is accurate. If I will give a new data point which is called the asterisk, which is the malignant cell, so output will be that this is the asterisk or the malignant cell when if our model is accurate. And again keep in mind the data which we provide, it should be labeled data. Why labeled data? Because SVM supports supervised learning, and in supervised learning we have the labeled data. Right, okay, now see here, this is the example. And what is the hyperplane means? These are my benign cells and these are my malignant cells. I want to separate these two because SVM says that it separates two classes. So here is one class, here is one class. I just made this blue line. See, when I will make this blue line, it clearly shows that now we have two separate classes. If a new point will come, definitely you will say it belongs to this class. This is the A class. Suppose if asterisk will come, you will say this is the B class. By using this hyperplane, this is called the hyperplane. Right, then after making this hyperplane we have to make two more lines which is called the decision boundaries. Now the question is, how I have made these two lines and what is the purpose of this line. So first of all, we will consider this set, right? Benign set. When we will consider the benign set, these are our opponent cells. So you have to find out the cell in this set, the blue set, which cell is closest to the opponent or closest to the malignant. So out of these cells, you can say this cell is more close compared to other cells to this group. Then you have to draw a line, and that line should touch this cell. This is the decision boundary. Then this we have to consider this set. Now this is the opponent set. So which cell out of these 6 or 7, which cell is closest to this group? So I said this one, right? This is also close, but compared to this one a little bit far from this. This is a little bit far from this set. This cell is closest to this one. We have to make a line which should touch this cell, right? So this cell and this cell, because on the basis of these two cells we have made this line, so these are called the support vectors, right? These two are called the support vectors because with the help of these two cells we are able to draw this line. Now see, you can see this is one distance, this is the hyperplane, and this is the decision boundary. So this is one distance, I say this is A, and from here for this group this is the hyperplane and this is the second, so I can say A dash, whatever name. A, in some books you will see A minus or A plus, A or A dash, whatever. When I will add these two, A plus A dash, then we have this line, right? This distance, this is called the margin. And margin is the important, very important point in order to find out which hyperplane we have to select. Right? Which hyperplane we have to select, it depends on margin. And what is the margin? The distance between this line and the distance between these two lines, we have a big margin. Now what I said, which hyperplane is best? You can say we have only one hyperplane, right? But I am coming to that point. Suppose I made this hyperplane. What is the meaning of hyperplane? It divides our two different cells into two different classes. This is one, this is one. So why, if I will draw a line like this, right? This is, if I say this is my hyperplane, this again divides these two sets into two different classes. This is class 1, this is class 1. If I draw a line like this, right? See, this is separate, this is separate. So why I am saying that this blue line is the hyperplane? That is why in order to find out which hyperplane is more suitable or more accurate, this margin is the important thing. How it works, I will show you here. See here, linearly separable data, right? We have these two are exactly same data points are here, same data points are here, only our hyperplane is different. So I'm going to show you why I said this hyperplane is good. Linearly separable data means, see, this is our data here, this is our data. If I will make a straight line which separates our data into two different classes, I said this is class A, this is class B, it is called linearly separable data. With the help of only one line, we separated two data points into two different classes. Right, again we have to draw these two line decision boundary. This is my hyperplane, in this case this one hyperplane, the blue line. The yellow line, same, you have to find out which cell is closest to this group, this blue one, and you have to make a straight line which should touch this one, this cell. Here two cells are touching. If you have three or four, same thing, you have to draw a line which should touch all the cells. So again, this is one distance from hyperplane to decision boundary, from hyperplane to this decision boundary, and this, if we add this and this, here suppose A and A dash, again we have this, and this is called the margin. If we have, suppose this is the linearly separable data, I will show you non-linearly separable data, which we will discuss in our next lesson, but I will show you what is the meaning of non-linearly. See, this is non-linearly, this is linearly, this is non-linearly separable data. Means if I make my hyperplane like this, it cannot divide this data into two different classes. See, asterisk is here, circle is here. If I will make like this, whatever direction you will use, whatever angle you will use, you cannot separate these points. So this is called non separable, non linearly separable data. Means with the help of one line we cannot separate this data. And how we can separate this data, we will learn in our next lesson by using kernel, but this is just the example. So this is the linearly separable. Now we move here. In this case, instead of making the straight line like this hyperplane, I made my hyperplane like this, and exactly the same one line I have to make decision boundary, decision boundary. This is A, this is A dash. When I will add this, I will get this. This is called margin. So I will say this is suppose M1, margin 1, this is margin 2. Now you have to compare the width of this margin. See this, the width of this margin is M2 is greater than M1. So you have to consider the hyperplane in which the width is more compared to other hyperplanes. This is called the maximum margin hyperplane. Right? So as I have mentioned earlier, that this margin is most important thing in order to find out which hyperplane is best. So the answer is the width. The width, this is the hyperplane, this is the decision boundaries. If the width is greater than the other hyperplanes, that hyperplane is more suitable, because if the width is more, it means we can classify two sets easily. We can make our model accurately. There will be no misclassification. Here we have misclassification. So as the width is more, less chances of misclassification, our model will be accurate, our future prediction will be accurate, less chances of errors. If the width is small, then there are more chances of misclassification, right? More chances of error, and our model will be less accurate. So I hope the concept of SVM and linearly separable data, which is separated by drawing a straight line, is clear. Please practice it, subscribe to my channel. See you in the next lesson, and thank you.